Assalamu alaikum everyone. Today the topic of our presentation is inventory management. Inventory management is the management of inventory or stock. It is an important element of supply chain management. To simply define inventory management, we can say that it is all about keeping inventory to an optimal level which serves the best trade-off between holding cost and setup cost. For managing inventory efficiently, it is essential to know when to restock, what amounts to purchase or produce, and what price to pay for an unit product. First of all, we need to understand why do we even need to hold an inventory. Customer demand is always unpredictable and uncertain. There is always a chance of anticipated or unanticipated increase in demand. To meet that demand, it is important to hold a certain amount of inventory. Besides, a quantity discount is often offered by sellers to entice buyers to purchase in larger quantities. So, if you buy goods in large quantities, you get the benefit of a reduced price per unit. To avail such kind of discount, it is essential to hold inventory. Sometimes it can also occur that suppliers are not being able to deliver a lot within specified time. To meet demands in those cases of delay in lead time, which is referred to as supply uncertainty, inventory is necessary. But the question is, how do we know the optimal inventory level? To answer this question, first we will need to discuss the economic lot size model. Economic order quantity or EOQ is an extremely simplified version of a real inventory system. The model assumptions are demand is constant, lead time is 0, and initial inventory is 0. We can see from the graph that as you increase the lot size in each order, the setup or ordering cost decreases, whereas the holding cost keeps increasing. The more stock you have on hand, the more you will have to spend on storage facilities, while increasing your risk of having products going out of date. EOQ solves this dilemma. It can be seen from the graph that total cost is minimum at the point where holding cost is equal to the setup cost. EOQ is the ordering quantity for which that happens. Now that you calculated the required inventory level, how do you decide when it's time to place a new order? For EOQ model, orders should be received at the warehouse precisely when the inventory level drops to 0. This is called the zero inventory ordering policy. EOQ is calculated assuming certain demand, but in real life demand is always uncertain. So demand forecast is done using the appropriate forecasting method. But the fact remains that forecast is always wrong and even worse when done for longer horizon. So should we order more than, equal to or less than the forecasted average demand? For that we need to know the concept of marginal profit and marginal cost. Marginal profit is the profit of selling or producing one additional unit of product, which is calculated by subtracting cost per unit from selling price per unit. Marginal cost is the loss associated with not being able to sell one unit of product, and it is calculated by subtracting salvage value per unit from cost per unit. So how do we make the decision? If inventory cost is greater than marginal profit, then order quantity should be less than the average demand and vice versa. If marginal profit is greater than the marginal cost, then order quantity should be greater than the average or forecast demand. Now we will see a case example of that. The bar graph shows the probabilistic demand forecast for swimsuits, which shows there is a 11% probability that demand will be 8,000 units, 27% probability that demand will be 12,000 units, and so on. There are some given parameters such as fixed production cost is $1 lakh, variable production cost is $80 per unit, selling price is $125 per unit, salvage value is $20 per unit, and average forecasted demand is 13,000 units. So, if we decide to produce 10,000 units, there are 6 possible scenarios. That demand will be 8,000, 10,000, 12,000, or 14,000 units, and so on. We can calculate the profit for each scenario by subtracting the variable and fixed cost from the profit. And then we can calculate the expected profit for each amount of production. Then if we place the expected profit on a graph with order quantity in the x-axis, we can see that expected profit is maximum for 12,000 units. So we can see that our optimal order quantity is 12,000 units where the average forecasted demand was 13,000 units. So why did that happen? We can see that the marginal profit is $45 and the marginal cost is $60. So here the marginal cost is greater than the marginal profit. which implies that the associated loss with not being able to sell one product and having to sell that on salvage value is greater than the potential profit from selling one additional unit. So, the optimal production quantity will be less than the forecasted demand. Now we will discuss two policies for random demand for a product where manufacturer has a fixed lead time. Distributors can go for either continuous review policy or periodic review policy. Continuous review policy is suitable for computerized inventory system. This system provides a more responsive inventory management strategy. It is assumed that daily demand is random and follows a normal distribution, and the distributor specifies a required service level. Service level is the probability of not stocking out during lead time. For example, if service level is 95%, it implies in 95% cases demand can be met, and in 5% cases demand can't be met due to the stock out of the item. Here we also need to know the concept of safety stock. Safety stock is the emergency stock you need to endure any unexpected occurrence. We can see from the graph that maximum inventory level is achieved immediately after receiving an order, and minimum inventory level is achieved just before the arrival of an order. And the average inventory is the average of minimum and maximum inventory level. For continuous review policy, reordering point can be calculated when lead time is fixed if we know the lead time, average demand, service factor, and standard deviation. And when lead time varies, to calculate the reordering point, we also need to know the mean and variance of the lead time. For example, retail shops such as Shopno, Minabazar, and Agora have a computerized inventory system where they can know the inventory from the barcode. So they use the continuous review policy and determine their reordering point accordingly. In periodic review policy, inventory is reviewed at regular intervals. It is suitable for systems in which it is impossible or inconvenient to review inventory continuously. For short intervals where inventory is reviewed daily, SS policy is suitable, where small s is the reorder point and capital S is the order up to level. For long intervals where inventory is reviewed on a weekly or monthly basis, base stock policy is appropriate. For SS policy, two inventory levels, small s and capital S, is defined, and during each review, if inventory position falls below small s, order is placed such that inventory is raised to the level of capital S. When inventory is reviewed weekly or monthly, the policy is characterized by base stock level. Base stock level is the target inventory level, and after each review, order is placed such that inventory is raised to the base stock level. So how to determine the base stock level? Suppose inventory is reviewed in each 30 days and lead time is 7 days. So current order should cover the demand of next 37 days, as the next order will arrive after 37 days. The objective of inventory optimization is to determine the suitable inventory policy based on desired service level. But who chooses the service level? Sometimes downstream customer chooses the service level, such as retailer fixes a service level for the supplier. For example, Shopno is a popular retail shop. If they want to maintain a service level of 95%, they will inform their supplier that they want to keep 95% service level, and supplier will design the inventory level accordingly. The higher the targeted service level, the higher the inventory. But if you want to keep the inventory level same and increase the service level, you need to shorten the lead time. So in that case, you select a supplier who can supply the product in shorter lead time. From this curve, we can see that if we want to maintain the inventory level at 440 but want to increase the service level from 94% to 99%, we will need to shorten the lead time from 4 days to 2 days. So this was all about the basic concepts of inventory management. Thank you everyone.